And we move to the mechanics homework booklet question 40. Sail systems are being developed to reduce the running cost of cargo ships. The sail and the ship's engines work together to help power the ship. One of these sails is shown in the figure below, pulling at an angle of 40 degrees to the horizontal. The average tension in the cable is 170 kilonewtons. Show that when the ship travels 1 kilometre, the work done by the sail on the ship is 1.3 times 10 to the 8 joules. So we're just doing a W equals Fs cos theta. The motion and the force are an angle, so I need to have that cos theta term in there. It's 170 times 10 to the 3, 170 kilonewtons, times 1 times 10 to the 3, the distance, cos of 40. And because it's a show question, I'm very deliberately giving too many significant figures, 1.302 times 10 to the 8, which of course is equal to what I was asked to show was 1.3 times 10 to the 8 when I take that to two significant figures. With the sail and the engines operating, the ship is travelling at a steady speed of 7 metres per second. Calculate the power that is developed by the sail. Now, power, force times velocity, where I think it's useful to think here of F being the component of the force in the direction of V. So I've got the 170 times 10 to the 30, and the component of that in the direction of the velocity is cos 40 times 7 the velocity, and again 1.116 times 10 to the 5 to two significant figures, 9.1 times 10 to the 5. We're then asked to calculate the percentage of the ship's power requirement that's provided by the wind when the ship is travelling at that speed. So if I'm trying to find the percentage of the power requirement, I've got to find out what the total power requirement is, and that will simply be the sum of the power from the sail plus the power from the engine. So that value plus the value from the engine, that gives me the total power requirement. So the percentage coming from the sail is the quantity coming from the sail as a percentage of the total, and that works out as 30.29, so to two significant figures, 30%. The angle of the cable to the horizontal is one of the factors that affects horizontal force exerted on the sail of the ship. State two other factors. The area of the sail, I think, is wrong button. The area of the sail is an obvious factor. Bigger area is likely to give me a bigger force. The wind speed's going to be important. Consider that as the wind power or the wind force, and the acceleration speed of the ship, because if the ship's moving very fast relative to the wind speed, then it's going to get less power than when it's still, because the winds will be moving past the sail more slowly. So that's the mechanics homework booklet question 40.